Cool. So last session we talked about the OBJ format, just for the stream viewers, because we briefly alluded to that already. And at the end, we had started to mock up a simple object loader, very primitive one, compared to what you will see and experience in the future. And you're obviously encouraged to write one yourself eventually. One that is to your convenience. I'll zoom in a bit so it's just barely legible. We briefly reiterate over it, but that is more like in order to get everyone back on track as to how the format actually looked like. Give me a second, I'll just bring an example file up as well. One of the more complex ones that we will encounter. No, it's not quite. So you may barely be able to read this. Unfortunately, this editor doesn't have a zoom function, but I just want to get the intuition across. We have, as Jonan pointed out, vertices, the vertex texture mapping. So if you have a texture that's attached to a particular model, then this is the UV mapping of the individual coordinates. And the next one were the normals that are attached to a particular vertex, right? So we can determine the side, the direction of the surface, and calculate reflective elements using this mechanism. Use MTL. So if you use additional features such as textures or material descriptions, which may not necessarily be rely on textures, you will need to import some library. MTL is the abbreviation for this one. We briefly went over the specification, and it's really about what did the material capture? What were some features that material libraries captured? It's not here. We briefly talked about it.
Reflective properties.
Cool. Reflection, right? So lighting, right? So diffusion components. There was this, now we know 11 parameter choice. Sorry?
Fragmentation? No, refraction. Sorry.
Refraction elements, yes, yeah. That's right. But there was some other aspect related to lighting, which was briefly alluded to.
The transparency?
Yeah, transmission elements, that's right. The other one was illumination, right? So you can model in how far the material behaves with respect to incident light. So, but one of the aspects that's also modeled in the MTL file is, or referred to, referenced in the MTL file, is the textures. And that's quite relevant as well. I will cheat and use the example that Ahmed provided us this week, because the best one I have to at hand right now. Hang on. Bear with me, we'll get there. So, I need to use different editors so you guys can actually read what I'm doing. So this, for example, is a relatively complex object here. In this particular case, a sphere you will be dealing with, but it similarly to the actually was not a good example. The other example is a bit better. There you go. So one of the other models you'll be dealing with in this in this next lab will contain. We talked about objects. So an object can be made up of vertices, but then you can also attach certain characteristics to grouped faces. So we talked about importing. That's very legible. Importing a material library and then actually using it. And when you, by indicating use MTL, you're suggesting that the material model for glass in this particular case, so it's just the name, is applied to the following faces. And the faces obviously are a combination of the vertices that have been declared before there. So just bring up the material file. So, and that's a representative material file that you will actually be using. And here's the idea that you model individual materials and have references. For example, the one glass we just saw here is specified here, and you have all the different parameters related to illumination, reflection, diffusion elements, and illumination models that are going to be applied, but also the potential, the textures that you'll be dealing with as part of this. So this is the way of linking vertices to materials and eventually to textures. So it's all done in the material file. So that's how the three things come together, basically, in a final model. So, but just to wrap up, last session I mocked up this object loader briefly. So the idea was basically that we automate the loading of models by providing a file path to a object OBJ file, and as a response we just want to have access to the vertices, the UV coordinates, and the normals to actually then send them to OpenGL in order to draw them. And the way we approach this in principle, apart from the funny comments you see here and there, is to read the file line by line, basically, and then on the fly determine what kind of entry we're dealing with, and differentiate between vertices, vertex textures, and normals, and put them into the corresponding temporary vectors. Yeah. So the tricky bit was, what was the tricky, or what, well, if there's anything tricky, what's the tricky bit of in the OBJ model with respect to linking everything together? Apart from just reading files line by line and putting into arrays, what's the challenging bit to produce vertices, UV coordinates, and normals separately? Does anyone recall? No? Perhaps it's too simple. That's good.
Just alignment.
Getting
just to get everything in the like right orders, and then when you then combine them at the end, nothing is misaligned and causes.
That's right.
I don't know, skewed.
Yeah.
Broken data.
The challenge is basically the faces, right? Because the faces can access any of the previously specified vertices or vertex normals or UV coordinates in an arbitrary, well, in the order they have been specified in, but it's not really relying on a particular order there and processing. So, and that makes it quite tricky. So basically you need to read all the indices of the individual vertices, textures, and the normals, and then iterate over the faces specification, which just has a one-based index to the individual entries, right? So, and then tie them up in order to produce the final arrays. So in the first iteration is really about this, and when we get to the faces, that's where the issues went a bit sideways. We identifying the faces specification and then read the entire line into the corresponding arrays. So we had the vertex array, UV, and normal array. And when I ran this, we kind of ended up with this thing in the the arrow comes up here, obviously. Good. So the arrow is basically a classical, okay, something went sideways, please do something, otherwise your code will explode. And so it turns out that we get an out of range error by when accessing the vector and actually adding a new element. That's the key idea here. And if we backtrack a bit, turns out this is happening down here, and right. And the issue is that we're trying to add to the final vector of vertices. We are trying to add an element that seemingly has the vertex index 9. And if we looked into your original file, where's the cube? Cube's not there. We'll get the cube. we actually find that we only have 8 entries here. So it's obviously the issue, so that we're accessing an index that we don't have access to. It simply hasn't been specified. So, so the issue is quite straightforward. I'm actually just having a misaligned, or what it is eventually. I just had a well, how do you call it? Misassociation or wrong association of the syntax of the faceless component and the corresponding arrays, vectors that I need to store the individual indices in, right? So recall that this is the x, the first, the second and the third element, and this was containing the vertex information, the vertex texture information, normal information, and so on for the vertices that are linked into a face, whatever that may be. So it's of 3 or more elements. And the issue that I had was basically my linking was slightly off. The fact that I was actually storing them in as vertex index 0, 1, and 2 was fundamentally wrong, because the second one needs to be a vertex texture coordinate as opposed to, vertex UV coordinate in this case, one of those, UV index, and this one the normal. So I got this allocation here wrong. This is the, that was the kind of glitch that I introduced into that model. I hope that makes sense. And after that, the idea is then to iterate, so to add those different elements and then iterate over those. So store all those elements in the corresponding temporary index buffers, and then iterate and use this vertex index information. So iterate over those ones and access the temporary vertex information using this index information, and then preparing the final vectors for vertices, UVs, and normals before, to be used then by the renderer. So the only thing that I need to fix here was basically make this UV coordinate. So see if my semi-systematic approach here fails me again. But again, a classical copy-paste problem. That I had not dealt with. That takes. And this is an N1. Right. So let's see if that works this time. That's luck. So, yeah, it's kind of working, but my mouse is cold. Oh, damn. For whatever reason, my machine is not helping my cause today. Well, it actually shows up, but I can't move the window. Okay. Yeah, instead of my mouse is gone. Anyway, all right. So the code for this simple object loader, just to reiterate over it and to have a look at it, perhaps is in the repository under examples, but obviously very primitive. Jonas did the same thing at the same time and wrote an object loader using an alternative approach. Did you finish that? No? Cool. Easy. Because your approach was slightly different, right? So the idea was there that you read the entire file first and then pass through the items. So different approach. But yeah, feel free to scrutinize the one that I uploaded, and then we can discuss that further. But so I don't want to assume more of the potential lab time, but rather shift to the lab that Ahmed produced. And the idea is there that instead of writing our own, we actually use one that is already developed in order to, to read models quickly. And also introduced the idea of having relationships between the different elements. We didn't talk about scene graphs or the like yet, so we need to do it in another session. It's not enough time right now, but for you it should be enough to play around with the ASIMP library and start getting comfortable with this for loading your own models and operating with this. And on Friday we'll catch up on the missing theory bits, I guess, to make that happen. So for now, I'd like to point you to this week's lab, basically. And everything should be available in the wiki. So it basically includes a bit of a run over the OBG features again, and then introducing ASIMP along with its kind of structure, internal structures, and how they actually work. But I think that's the full working example that you provided, right? So, and then you guys can explore that and modify it according to what we did. Plus also perhaps introduce and play with lighting elements like this. So it's a fully working example, but the idea is that you use it as a starting point to modify and play with this. Perhaps modify lighting position, or simply play with the library itself and using other models to actually load them into ASIMP and then render them accordingly. Is there anything else I need to add with respect to that?
Yeah, it's just ASIMP library. They can find online documentation. It's already available. So the only thing they need to know different about this lab is just how ASIMP renders the scene. So, and how you find each vertices, how you find the meshes, and how you navigate the ASIMP data structure, basically. Mm. So there is nothing new. Just know how this is actually the AI scene, the way how ASIMP organizes its files. So once you understand that one, this is easy. Just easy extension of the previous labs. Just create VAO and VBO and load it and something like that.
Right. So we have an AI scene that has a number of meshes, then the actual mesh elements, right? Yeah. So they consist of the now faces, vertices, normals, so all the information that you actually have in the OBG format, right, is mapped basically into a different data structure form here. And in addition to the meshes here, then you have separately the materials that are linked from the corresponding meshes, and yeah, the parent node, right, that brings everything together. I think so it should be from a
yeah, and the number of materials in the texture and the materials, you can find them. So just go through the lab, the code, and just explore.
Yes. So yeah, it's in Lab 7, in the Lab 7 subfolder. Again, there's a bit of a dissociation between our weeks and the labs, but it's Lab 7, so as indicated in the wiki, just check it out and compile and see if it works.
Week 9.
Week 9. Yes, we can. Okay, but the lab is called Week 7. Lab 7, sorry. But Week 9. Thanks. That's a good. Thanks for reminding me of those things. That's quite helpful. That reminds me of something else we can talk about. But independent of that, yeah, check it out. Compile it. It should be Mac compatible. Good luck. It's definitely tested on Linux and on Windows. So
last lab worked out of the box on Mac.
Oh,
congratulations! That was the first. Yeah.
Cool. So I'll switch off the stream at this stage because I don't think there's much value of keeping it running.